The purpose of making this video is just to do a follow-up to what we did in class. Of course, in class, I actually walk you through how to, you know, develop a T distribution and F distribution. Of course, the significance of T and F distribution in statistical analysis is if I want to conduct a t-test, I'm actually going to do that in the territorial jurisdiction of t-distribution. And if I want to conduct an f-test, that will call the analysis of variance test, where we compare, the means of more than two independent groups. Of course, we're going to make use of another test that we also call f-test. And of course, we can only do that if the F distribution is known. And of course, we can do one sample t-test, two sample t-tests using the territorial jurisdiction of T distribution. Now, so what I want to walk us through now are how the way actually theoretically develop the T distribution. That's going to be the purpose of this video. Maybe in another video, I'm going to walk you through how to derive that of F distribution. But if time permits me, so I can also look at that of F distribution. So what we want to do now is just how do we actually derive our T distribution? Because if I want to conduct t-test, the assumption is that I'm using a T distribution. Of course, when you conduct a t-test and you want to figure out the p-value, okay, associated with the test so that you'll be able to take a decision regarding the null hypothesis and the alternative hypothesis. Of course, you basically need, T distribution, okay, for that. And even if you want to check statistical table, where you want to check, given a certain degree of freedom, you want to check for critical value of T. Are you ever, do you ever wonder why, how those values in the statistical table, how they were actually simulated? So I'm putting it to you now, the one for T distribution. The one for T table, we actually use the density function of T, okay, to be able to simulate that. Okay, so I'm actually going to share, I'm going to share my screen right now for me to be able to walk you through that. Now, when you're talking about, T distribution, we'll realize that it is actually h of t equal gamma r plus 1 over 2 divided by gamma r over 2 square root of pi r. Then I'm actually going to have 1 plus t squared over r, then everything raised to power r plus 1 over 2. Now, what we have here is what we call T distribution. Okay, this is the statistical architecture of that. That we call the probability density function of T distribution. Okay, so when you have this guy now, the range of T is from negative infinity to positive infinity. Now the question now, so how do we actually derive that? Okay, so how do we derive that? So if I want to derive that, we're actually going to start from, so we want to start the proof now. And I need you to follow me with the way I'm going to do the proof. Like I said, I'm actually working on T distribution. Okay, I'm working on T distribution, like I said. Okay, now it is the ratio of Z to V divided by R. Now, do you know my z and my v, they are random variable. Okay, r is just the degree of freedom. Okay, so z is a random variable that follow normal distribution. Okay, with mean of 0, variance 1. So which that is actually saying that my f of z is 1 over square root of 2 pi exponential raised to power minus r z squared. Okay, so where z is going to go from negative infinity to positive infinity. Now, what about v? Okay, v actually follow chi-squared distribution with a degree of freedom r. And if I want to write the density function of a chi-square distribution, so the chi-square distribution is going to be f of v. Okay, so I'm actually going to have v raised to power r over 2 minus 1 exponential raised to power v over 2 divided by gamma r over 2, then 2 raised to power r over 2. And of course, the range of v is from 0 to infinity. Now, when you take a look at what I have now, in statistics, that's, just like what I used to tell people, there's nothing new on that is on. All we're just trying to do, when you get a new one, it's just modified. When you're trying to modify the old version, we get a new version. When you take a look at the chi-square distribution here, I told I walk you through in class the other time. The origin of the chi-square distribution can actually be traced to the square of standardized normal distribution. When I square standardized normal distribution, I got a chi-square. Not only that, when I have a gamma distribution with a parameter alpha and beta, if I plug in beta to be 2 and I plug in alpha to be r over 2, I'm basically going to have a chi-square distribution. Okay, so I just wanted to take note of that. Now, you now have, we got v and z, okay, that are random variable. I've already written their, their respective probability density function now. Now, what I'm basically going to do now, okay, is to actually, use the fact that the two variables that I talk about, actually, um, they are independent. Okay, so if z and v are independent, okay, if they are independent, it means using the idea of what we did in class about independent. I'm basically it's gonna be f of the joint will be equal to f of z multiplied by f of v. You know that, right? We are the probability of the joint occurrence of z and v that follow different distribution is basically going to be a product of their marginal. So what I'm going to do now, I know, for looking at the probability distribution for z, I got 1 over square root of 2 pi exponential raised to power minus half z squared. And of course, that's of the chi squared. Okay, we got v raised to power r over 2 minus 1 exponential raised to power minus v over 2, gamma r over 2, then 2 raised to power r over 2. Now, when you take a look at what I have now, okay, this is like, I want to multiply the marginal distribution of each variable. So what I just want to do now is to simplify, okay? So if I'm actually going to have this guy, okay? I'm going to combine this guy and that guy. So I'm actually, if I factorize half out, then I'm going to have z squared. Okay, so when I actually have z squared now, okay, half is actually coming out. So I'm basically gonna have what I have now. So divided by the square root of 2 pi, gamma r over 2. Then I'm actually gonna have 2 raised to power r over 2. So this is what I'm actually gonna have when I try to simplify. Okay, now this is going to be using the idea that the z and v are stochastically independent. So because they are independent now, so that is what I actually got that. Now the next thing I actually want to do is going by what we given before, t equal to v over r, where we actually want to go from z and v, okay, to t. It is not possible moving from two variables to one variable. So I think we need to create an artificial variable. Okay, maybe I can just say artificial variable u, but the artificial variable that I'm actually going to create it's going to it must have to something to do with the denominator. The variable in the denominator is v. I'm actually going to say equal to that. It's more or less like maybe they invite a couple to a party, and maybe my wife is not around, and actually want to go into the party. Okay, if I want to go into the party, maybe I say, okay, let me just call her my daughter. Okay, let my daughter represent my wife at the party. But the moment I only use my daughter to stand in for my wife at the party, or by the time we actually uh, done with the party and we get home, of course, I'm actually my daughter can stand in the place of my wife anymore, which is what I'm actually gonna do here. So what is acting as my daughter now is you. Okay, initially there was no u. We actually created u because so that we'll be able to move from two variables of v or z and v, okay, to t and u. But in the end, I'm actually going to integrate out that particular u. Okay, just like the same way that in order to be admissible to the couple party when my wife is not around, and I call on my daughter to actually stand in. The moment we are done, then I'm going to integrate out my daughter. That's what I mean. Okay, so based on what we have now, so I'm actually going to, you know, um, uh, because I want to go from f of z and v, I basically want to go into t and u. Okay, so what I'm actually going to say is that, okay, I want to express z in terms of t and u, and also to represent presently I have z. Then I'm also going to represent the same way that I represent z in terms of that. I'm also going to represent v in terms of t and u. And the moment I've done with that, I'm actually going to multiply by the determinant of Jacobian. Okay, so what I'm for us going to do is to for us do that here. Okay, so yeah, I'm actually going to have v to be equal to u, which is I'm actually doing this. Then I'm also want to do this now. I'm going to come here, so we're going to say z equal t. So instead of the square root of v over r, now that u equal to v, I'm actually going to write u over r. Okay, so if you take a look at this now, so anywhere I see, u, anywhere I actually see V, I'm going to plug in U. Anywhere I see Z, I'm actually going to plug in T square root of U over R. But I need to first, I need my Jacobian, okay, because, I mentioned Jacobian the other time, right? Okay, so actually, give me 1 second. I'm going to clean up this guy, okay, because I still need this. So maybe I'm going to set up my Jacobian here. So my Jacobian is just going to be the V, the T, okay. And I'm also going to do the V, the U, okay. Then when I do that, I'm also going to do the Z, the T, and then the Z, the U. Okay, so which means I'm coming back in there. Okay, so what is my DVDU? That's going to be 1, right? Sorry, that's going to be 0. Okay, give me 1 second. Yeah, that's going to be um, second. So that guy is going to be 0 because there's no T here. Then I'm going to do the VDU, which is basically going to be 1. Then I'm going to come here now. I want to do the Z, the T. Okay, doing the Z, the T. So I'm actually going to have square root of U over R. Then I want to do the Z, the U. Okay, so the Z, the U, I think I'm actually, half is going to come down. Then I'm actually going to have U raised to the power minus R. Then I'm going to have the square root of R. Okay, by the time I find the determinant now, okay, so that, and that and that, of course, my determinant is basically going to be square root of, give me 1 second, going to be square root of U over R. So it's going to be square root of U over R. Now, the square root of U over R now become the determinant of my Jacobian. Okay, so I got the Jacobian of 2 by 2 because of the fact that two variables are actually involved. So what I'm gonna do now, okay, since I already have what I need, so basically, okay, so I'm basically gonna come here. Okay, so I want to get h of t u. Okay, now the other time I think I actually uh you know giving z, don't forget, give me 1 second, giving t to be equal to z over square root of V over R. Okay, don't forget that I said U equal to V, and of course, and I said from there V it will be equal to U, and of course Z will be equal to T square root of U over R. Okay, so anywhere I say V, I'm actually gonna put U. Okay, here. Okay, I want to focus on this guy now to be able to get my, the h of t u. So my v is going to be u. Okay, it's going to say, write u. Okay, raised to the power r over 2 minus 1. Okay, exponential raised to the power minus r. Then what is my z square? I'm going to square this guy here. So which is going to be t squared u over r. Okay, plus v, and my v is actually u. Okay, so divided by square root of 2 pi. Okay, and then when I have square root of 2 pi, then I got gamma r over 2, then 2 raised to the power r over 2, then multiplied by this guy, which is basically going to be the determinant of Jacobian. Now what I have now, I got HTU. Now when you take a look at this HTU now, it's more or less like my me and my daughter, we're already in the party now, right? That couple's party. Okay, my wife is not around, and my daughter is actually representing my wife. But what we actually need is the distribution of t. So what I'm just going to do, if I want to get a distribution of t, then I need to integrate out the joint with respect to the variable that has to do with that my daughter. I'm actually integrating how, and I'm going to use the range of u, the range of v was 0 to infinity, that, and v equal to u. So u is also going to have that. So what I'm just going to do now, okay, I don't want to rewrite this, so I'm just going to put give me 1 second. Um, I'm just going to call this guy h of t, and I'm going to put it 0 to infinity, and I'm going to put the u. Okay, so that is what I want to, you know, uh, integrate now. Okay, this is what I want to integrate now. Okay, so but before I can integrate this, I need to first like simplify, bring out some terms that are independent of u. I think you know that, right? Okay, so with the one I'm actually going to bring it out. Okay, I'm actually going to bring out the square 1 over square root of that, the gamma r over 2, 2 raised to power r over 2. Okay, and if I actually do that, there's a square root of r here that's also going to come out. Okay, the square root of r that's going to come out. Then I'm actually going to be left with 0 to infinity. Okay, now we take a look at this guy. And if you take a look at this here, you're going to see that that is u raised to power half. Okay, by the time I add the half to that one, I'm actually going to have u raised to power r over 2 minus half. Okay, so don't forget there's a half there. Then I'm actually going to have exponential raised to power this guy, and u is common, right? I can actually bring the u out. Then when I'm bringing out, I'm going to have t squared over r, okay, plus 1. Then the u, take a look at that. Okay, that is what I'm actually going to get now. It's taking shape. Okay, so when you take a look at this guy, give me 1 second, let me rewrite. That is going to be u. Now, when you look at this guy, I want to use what I call, gamma function, but this is not in a proper mathematical standing. How to use a gamma function. I can first use a substitution rule. So where I can say, okay, let P be u over 2 or t squared over r, okay, plus 1. So where I'm actually going to say, here this implies u to be equal, to p, okay, divided by t squared over r plus 1. Okay, so u is going to be equal to that. I think, you know that. Then I also need the p. I need the p, the PDU. Okay, the PDU is just going to be t squared over r plus 1 divided by 2. And because I want to substitute for the u, okay, because I can't use that the u anymore. So if I want to substitute for the u, okay, the u is basically going to be 2dp, okay, divided by t squared over r, okay, plus 1. That's what the u is going to be. So all what I'm just going to do now is to start plugging them in. Okay, so if I want to start plugging in, the u here is basically going to be this guy. Okay, so which means here, I'm actually going to use 2p divided by t squared over r plus 1. Okay, and this guy here is always going to carry p. Okay, so it's going to carry p. And instead of using the u, give me 1 second. Now the u now, okay, my du, if you take a look at what I have here, my du is going to be 2 dp, okay, divided by t squared over r plus 1. Okay, that's what I have right now. Okay, so if I have that guy now, I want to clean up. Okay, I got a lot here. I want to clean up. This is where we are now. So the next thing is just for us to simplify. So if I want to simplify now, okay, you're gonna see a 2 here, right? Okay, which is gonna be, I can write it out, 2 raised to power r over 2 minus half. And there's another 2 here that is carrying 1, so I can do plus 1, right? Okay, so that is actually coming out. Okay, if that guy come out now, then I'm actually going to have divided by square root of 2 pi gamma r over 2, 2 raised to power r over 2, square root of r. Now, when you take a look at here, you have t squared over r plus 1 carrying as a power of r over 2 minus r. And I also have it here. So I'm actually going to combine them. So when I combine them, it's going to be t squared r plus 1 raised to power r over 2. Okay. And because I'm actually having minus half, okay, plus 1. So it's going to be plus half. Okay, so I'm now going to have integral. What am I going to be left inside here? It's going to be p. Okay, p r over 2 minus half, then exponential raised to power minus p, just the p. And don't forget 0 goes to infinity. So I want to use a gamma function here. Okay, I want to use a gamma function now. Okay, the range of v is still going to be 0 to infinity. Okay, I want to use a gamma function. If you look at what we've done in class, that's going to be, you're going to add 1 to the power of p, which is going to be gamma r over 2 minus half plus 1, which is going to be gamma r over 2 plus 1 over 2. So if I'm going to clear my board now. So you basically, you're going to see what we got. Okay, so what we got now, when you take a look at this guy actually cancel the guy here, okay? And if that guy cancel that guy, I'm going to be left with 2 raised to power half, which is square root of 2. The square root of 2, we actually cancel the square root of 2 here. I'm only going to be left with the square root of pi. So if I want to rewrite the whole thing now, I'm actually going to have 1 over square root. Here I'm going to be left with square root of pi. There's a square root of r. I can combine them. Don't forget, I'm actually writing, give me 1 second. I'm actually writing my h of t, which is going to be 1 over square root of pi r now. Okay, so I'm going to take that guy and actually having gamma over r over 2. Then I have t squared over r plus 1 raised to power, I can do r plus 1 over 2. And this guy here is just going to be gamma, when I had to the power, when I had 1, I'm actually going to have r over 2 plus 1 over 2. Take a look at that. Now, what I just need to do now is to actually simplify, and let's see whether we are already at our final destination. Okay, we're going to see now. Okay, so what we're going to have now is going to be 1 over square root of pi r. Okay, gamma r over 2. Okay, and of course this guy, I can actually put it here, so where I can even write r plus 1 over 2. And of course, where this guy go up, so I'm actually going to have t squared over r plus 1 raised to power minus r plus 1 over 2. Therefore, this is a t distribution where our t lies between negative infinity and positive infinity. Okay, this is the distribution we talk about. So this is the distribution that we actually use